Okay, this video is going to be about Holley base plate warpage and the main body. What I have here is a outboard carburetor from a 446 pack. This pertains to the Corvette Tri-Power, which is, you know, real similar. What happens with these base plates is when they have the gasket underneath them and they're being torqued to the manifold, people are over torquing the hell out of these bolts. And what happens is the gasket in the center here, the only torque being applied to that area is these outboards. So what's going to happen is that outer edge of the gasket's going to start crushing. The center doesn't have as much torque, so it's bunching up. And with the heat of the engine, this base plate's going to start taking a frown like this, and then it's going to transfer up to slightly frowning the top edge, which translate into it'll start frowning the base of the body. So when I do these carburetors, and what's going to happen is where the problem is when this frowns, it also changes, it also bends over the throttle shaft bore. So what will happen is you know, you'll pull these off, or even when they're on the car, and you'll have the shaft in here, and it's binding. You know, this is like the correct position. This arm would be down like this, and they open like this and close. So what's going to happen is this thing is going to be like binding. It's going to be tight. Now these vacuum secondary type operations, these shafts have to move with no restrictions. So when I do these carburetors, and this is Holley 4 barrels and, you know, some other types of carburetors that I have to do this to, is I flatten this side. You know, first I use a file, and then I put it on a granite stone that I got some, you know, like a 400 grit paper glue to it, and then I just, you know, I rub it. I get this pretty flat, because when you go into a milling machine, you need a flat surface to correspond to make another flat surface. So then this basically gets bolted to my mill plate. I surface this side. I know it's flat and parallel to the other side. I flip it over, and then I kiss this side. So now I know I got two flat parallel surfaces. But it doesn't address the issue if I have binding, because this is not going to straighten out the bore. So, you know, and it's not all of them. It's a percentage. But I have to check all this stuff, you know, to make sure that, you know, I've got, you know, free movement of the shaft. You know, no interference. When I find ones that have an interference in here, then what I have to do is I have to go in and I have to align bore the, you know, the whole shaft bore. And I align them off of the center, you know, and, you know, I have to have a reference point to align bore it. I align bore it, and then I'll install bronze, you know, oiled bushings. You know, they got oil impregnated in them. And the next thing is you have to determine, where do I have a problem at? Is it the base, or is it the manifold? Now you'll see on a lot of Corvette Tri-Powers, because the manifold's so low, there's a lot more heat, and those surfaces are prone to warping. And so you want to determine if I got this thing off and it's moving freely, and then I go and with a brand new gasket, you want to do this, and I put it down and I snug up. You just want to snug those outer bolts, don't be cranking on them. And then I tighten it down on the manifold. Is this shaft binding? If it is, that means that your manifold has got to warp. Now, most of the time on aluminum manifolds, you can correct that problem. You'll get rid of the studs off the manifold, and you get a good aluminum file. you know, like get a Nicholson file, because you got to make sure that the file is straight. You buy cheap knockoff overseas files and they won't be flat. And what you want to do is run that way. You'll see high and low spots, or where the warp is, and you basically hand file them till it gets flat. You know, make sure you put something in the bores, keep the metal dust out. Or your next best is to remove the manifold, you know, bring it to a machine shop and they'll, you know, kiss all the surfaces. But this method works. And now I'm gonna show you how I test these bores under a torque load. Okay, basically what I'm going to do is just make sure that my work is all correct. And I know these things are flat and parallel, but just to double check them, this is a flat surfaced plate. And what I'm going to do is I'll bolt this down. Like so, and that's as much as I'm snugging them, and that's all you need when you're putting this on the car. You know, you don't get on the end of this wrench and start cranking. So then what I do is I put the shaft in, the right location side it's going in. I put the shaft in, put it in this position, and I rotate it. Now you guys can see how easy that, just no resistance. So next I'm going to show you how I test it to the body. So what I've done is I've torqued the base onto the body. Now remember, these bodies have been milled, base has been milled. So now what we're going to do is put the shaft in, and I'm going to check to make sure it's free. No binding. And then what I'll do is, you know, I'll put it back on here and torque it down one more time with the complete assembly, and then I'll check the shaft. You know, I just go through these test procedures just to, you know, to verify, you know, once I got this thing all assembled, if I got problems, you know, then I got, you know, finished stuff, and I got to start doing machine work. But like I say, if I do have a shaft out of alignment issue, I'll line bore them, install bushings. That takes care of it. But you know, when you set these up on your car, you want to make sure once you got them bolted down that these shafts move real easy. You can disconnect your vacuum bipod, take the little C-clip off and unhook it, just so you're just testing the shaft only, and the bipod isn't giving you interference. Just a tip. Hope this helped you guys out.